In numbers 4 through 7, we're going to be doing something almost exactly like what we did in number 3. However, in number 3, they gave us the equations already graphed. But in 4 through 7, as you can tell, the lines are not there. We have to graph them ourselves. So in order to solve by graphing, we graph each equation in the same coordinate plane, so on the same grid. The first thing is that the equations must be in slope-intercept form. Slope-intercept form is y equals mx plus b. Okay, and then it says the second thing is to graph each line. We begin with the b, so that's where we start, is we start with the y-intercept. And then we move with the m, which is the slope, the rise over the run. So begin with B and then move with M. So let's try that on number 4. They've given us two equations, and again, remember that the two equations together form a system. And these both happen to be in slope-intercept form, in y equals mx plus b. Okay, and so now we need to identify both the m and the b in each equation in order to graph it. Okay, so let's start with y equals negative x plus 3. Our m, the slope, is equal to negative 1 because that's the number in front of x. And b is equal to 3 because that's the number that is by itself. Alright, let's go ahead and graph this one. So again, we begin with b, which is the y-intercept. So we go to the y-axis and we plot a point at positive 3. Now we must move with the slope, which is m. Remember, slope is a fraction because it's rise over run. So if it's a whole number, which is what we have here, negative 1, to make it a fraction, we put it over 1. So negative 1 over 1 means I'm going down 1 into the right 1. So down 1 to the right 1, and I'm going to keep going down 1 into the right 1 till I cannot graph anymore. Okay, and then if I go the opposite direction, that means I'm going to go up 1 to the left 1. Okay, then connect your line. Alright, so there's the first line. Now we need to graph the second line. The slope of the second line is positive 1, because that's the number in front of x. Even though you don't see it, remember when you don't see a number in front of x, it's an understood 1. And the b, the y-intercept, is a positive 5, because that's the number that is by itself. Okay, so again, we begin with b, which is our y-intercept, so we begin at a positive 5. So let's go and plot that point. We go to the y-axis, and we go up to a positive 5, right there. Okay, and then we move with our slope, which is m. Remember, slope needs to be a fraction, so if it's a whole number, we put it into a fraction by putting it over 1. So and this time it's a positive 1 over a positive 1, so that means I'm going up 1 to the right 1. Well, I've run out of room going that way, so I'm going to go the opposite way, which means I'm going to go down 1 into the left 1. And now connect your line. And there's our second line. Okay, so because our lines are intersecting, that means we have one solution, and our one solution is going to be a point with an x and a y value, and the solution is found where the lines intersect. So right there. And the coordinates for that point are x equals negative 1 and y equals positive 4. So this point right here is our solution. That is our final answer. Now I want you to pause the video and attempt number 5, It is exactly the same process of what I just did on number 4. So pause the video, complete number 5, and when you're done, press play and see if you got it right. Alright, so on number 5, the solution I got was 2, 3. This system has one solution because the lines are intersecting, and that one solution is a point with an x and a y value. Now let's try number 6. What do you notice as different about number 6? Hopefully you notice that the equations that they gave us are not in y equals mx plus b. They're not in slope-intercept form. They are given to us in standard form. ax plus by equals c. So what can we do with this standard form to get it to slope-intercept? Well, we're going to solve for y. So we need to solve both of these equations for y. I'm going to move this over here, and we will, hold on. Okay, now we have room to solve it out. So the first equation is 6x plus 6y equals negative 3. We need to get the y by itself. So let's move 6x to the other side by doing the opposite to get it to the opposite side. So minus 6x, and what we do to one side, we must do to the other. Our 6x minus 6x is going to cancel out. Bring down our 6y, bring down our equal sign. We cannot combine a negative 3 and a negative 6x, so we list them out. Alright, now we need to get rid of that 6 that's with the y. So they're being multiplied, so we divide every term by 6. Well, our 6's will cancel out on the left side, so we're left with y equals, and negative 6x divided by 6, that is left with a negative x. And negative 3 divided by 6 will simplify to a negative 1/2. So there is one equation in slope-intercept form. Okay, now we have to solve for the other one. So we take the second equation, negative 6x minus 6y equals 3, and we have got to get the y by itself. So draw your line down from the equal sign and start solving. We need to move that negative 6x to the opposite side, so we do the opposite and we add 6x to both sides. The negative 6x and the positive 6x will cancel, so we bring down the negative 6y, bring down your equal sign, and a positive 6x and a positive 3 we cannot combine, so we just list them out. 6x plus 3. And now we need to divide by negative 6. Every side, every term. The negative 6's cancel out, and we're left with y equals negative x, and then positive 3 divided by negative 6 will reduce to negative 1/2. So there's our second equation. What do you notice about the two equations that we got that were in slope-intercept form? This one compared to this one. Hopefully you notice that they are the exact same equation. So even though they looked different the way that they were given to us at first, their slope-intercept forms are the same. That means when we graph them, they're going to be the same. So let's go ahead and do that. The m in these equations is m equals negative 1, because that's the number in front of the x. And the b, the y-intercept, is negative 1/2, because that's the number by itself. Okay, go ahead and pause this and practice graphing this one on your own. hopefully you got a line that looks like this. And again, there's not two lines because both of the equations that we got were the exact same. So when we only have one line that is graphed, but two different equations, that means that we have infinitely many solutions. And if you guys remember from when we talked about this with equations, we just wrote it as IMS, infinitely many solutions. So that would be your answer here. Alright, now you try number 7 and follow the same process that we did in number 6. Notice that the equations are given to you in standard form, but again, we must have them in slope-intercept form. So you need to take both of these equations and solve them for y. Then identify the slope, which is m, and the y-intercept, which is b, and then you can graph both of them to determine how many solutions are there and what are those solutions. So pause the video, attempt number 7, then press play and check your answer. Here is the first equation solved for y. You should have gotten that y is equal to negative 4/3 x plus 17/3. It's okay that you have fractions. Okay, so our m here is negative 4/3 and the b is 17/3. Alright, so now make sure that you got the second equation solved correctly. Here is the second equation solved for y, and you should have gotten that y is equal to negative 4/3 x minus 17/3. So notice that your equations are actually very similar. They have the same slope but a different y-intercept. The key here is that they have the same slope, so think about what kind of lines have the same slope. If you're not sure, you'll find out in just a moment. Okay, so our m here is negative 4/3 and b is negative 17/3. Alright, so now go ahead and make sure that your graphs are correct. So here's the graph of both of your lines. Notice that they are parallel. They will never cross, and that is because they have the same slope. Okay, so because they will never cross, that means they'll never intersect. So if they never intersect, they can't ever have a solution. So our answer here is, hold on just 1 second. Our answer here is no solution.